Hello everyone, welcome back to STR8CHEM. In this video, we are going to learn about salt hydrolysis. To begin, let's have a look at what does it mean by salts in ionic equilibria. So salt simply means the ionic compound that is formed when you have an acid reacts with a base. You have an acid, and then when you add that with a base, a salt will be produced. Let's have a look at this general neutralization equation right here. This is the acids that you have, and then when you react that with the base, what we are going to be producing is the salts, and of course also water molecule. So when you have your acid react with the base, you're going to have your salts and your water molecule. In this video, we're going to talk about salts and how these salts will be able to have basicity, acidity, and even neutral salts. So this is your acid, remember? And then that is your base. And what will be produced is a salt. And this is the thing that we're going to be talking about in this video. So basically, there are three types of salts. We have neutral salts, and we have acidic salts, and also basic salts. Another important thing that we need to know about salts is salts will be completely dissociated in aqueous solution to form cation and anion. So when you have let's say your salts over here, and if we take this in a form of solid and you dissolve that in aqueous solutions, you will have it in a form of cation and anion. They will be completely dissociated to form these two ionic species. So that is going to be your salts. And when you dissolve that in aqueous solution, like what we have in the general equation for neutralization. So this salts over here is dissolved in aqueous solution. What you have is the production of cations. And yes, you have your anion right here. Now let's have a look at what type of salt is made when strong acids and strong base react together. Let's say we're going to take the example of hydrochloric acid. This is a very common example for strong acid, and it will react with sodium hydroxide, which is also a very well-known strong base. When both of these solutions are reacting together, they will be producing water and, of course, the salts. So water will be produced, and the salts that will be made will be sodium chloride. Okay, so we want to know what is the nature of these salts being produced when you have strong acid and strong base reacting together. So in water, NaCl, sodium chloride, that is produced here, is completely dissociated into, we have the sodium chloride just now. When you have this dissolved in water, it will be completely dissociated into Na+. and Cl minus. Okay, so salts, like what we have talked about just now in the beginning of the video, will be completely dissociated in aqueous solution to form the cation. So this is the cation with the positive charge, and the anion with the negative charge. Both Na plus and Cl minus over here will not gonna be reacting with water, although they will be dissociated in water, but they will not gonna be reacting with water because sodium hydroxide has a low polarizing power due to the low charge +1. And the chloride ion over here is a very weak conjugate base, and therefore it has no affinity for H plus and no tendency to hydrolyze the water. So what can we say? Anion from strong acids, cation from strong bases. Okay, so the anions from the strong acids just now is, remember, the anion is the Cl minus. So do you remember that this Cl minus came from HCl? Okay, like what we have seen in here. The Cl over here came from the HCl, which is the strong acid. And when you have that completely dissociated in water, this anion from the strong acid and the cation from the strong base, they will not gonna be reacting with water. So the cation that we have in the example is Na plus. Both are ionic species from strong acid and base. So if you have that dissolve in water, they will not hydrolyze the water molecule. So when there is no hydrolysis of H2O happening, what happens to the pH? The pH of the solution will be equals to 7. So what is being made in here? So basically, if we have salts of strong acid and a strong base mixed together, the salts, when it is dissolved in water, the pH of the solution of the salts, okay, solution of the salts is equals to 7. So what can we say about the salts? The salts is a neutral salts. So other examples of strong acid, strong base salts, we have NaNO3, KNO3, Na2SO4. So these are the other examples of strong acid, strong base salts, and they are all neutral salts. Now let's have a look at what happened when we add strong acids and weak base. What sort of salts will be produced? Before that, we're going to look at one example of strong acid. So we're going to take the most common one that we have also done just now for the strong and strong. We have hydrochloric acid. So we do know that this is one of the most common strong acid. Okay, and we're going to add with another quite common weak base, ammonia. So this is your weak base. When we add hydrochloric acid, which is the strong acid, with the weak base of ammonia, it will be producing a salt, because this is also a neutralization process regardless of strong and weak. Therefore, the salts that will be formed is NH4. Why we have NH4? Because the H from hydrochloric acid will be donated to your base over here. It will be becoming NH4, and the Cl will be attached to that one as well. And we have this salts. Okay. So like any other salts, NH4Cl will be completely dissociated when we add into water. So NH4Cl, NH4 here, originated from the weak base, and the Cl right there originated from the strong acids. Remember that? So when we have this salts right there, when you add into water, it will be dissociated completely to become NH4 plus aqueous and chloride Cl minus aqueous. Remember, the chloride ion right here, Cl minus, comes from the strong acids. Therefore, you can guess that the Cl minus will not going to be hydrolyzing the water. But since NH4 plus comes predominantly from the weak base, it will be having some sort of hydrolysis. So the anion from strong acids, so remember, the anion from strong acids will not going to have any kind of hydrolysis with water, so it will stay like that. But the cation from weak bases, in this case, we have NH4 plus, so the cation will be reacting with the H2O. So what happened here, it will donate, NH4 plus will donate a proton to H2O. So what happened? The cation, which is NH4 plus in this example, donates H plus to the H2O liquid and forming H3O plus aqueous. So when you have this being formed, that is the indication that this is going to be acidic solution. When you dissolve the salts in water, it will be acidic. So this is the example right here. You have NH4Cl aqueous dissolved in aqueous solution, will dissolve completely to become NH4 plus and Cl minus. This Cl minus over here will not going to be reacting with your water molecule because it comes from the strong acids. Remember, when this one comes from the strong acid, it will not going to be reacting with water. But since NH4 plus comes from the weak base, it will have a reaction with water molecule, and you have this being produced. Okay, so like I said, when you have H3O plus, or the name of it is hydronium ion being produced, that is the indication that the reaction over here or the solution over here will be acidic. So since H3O plus is being produced, the pH of the solution of the salts will be less than 7 because it is acidic. Why? because like what we have seen just now, H3O plus is formed when the salts is dissolved in water. So what can we say about this? It is an acidic salts. Other examples of acidic salts like this and that. So these are the other examples of acidic salts. Okay, so now finally we're going to look at what happened when we are going to be adding weak acids and strong base together. We will be looking at what sort of salts will be produced. So let's take the example of vinegar or acetic acid for the weak acid. It's a common weak acid that we have been consuming as well. This is the structure of the weak acid. And it will be reacting with a strong base. Let's say we're going to be using another quite common example for strong base, sodium hydroxide. And upon reacting together, both of them, they will be making a salt and water molecule. We have water being produced, but the most important thing that we are going to be looking at is the type of salts they will be forming when reacting together. The salts will be CH3COO and A. So this is the salts being produced. This part of the salts came from the weak acid, and this part of the salts came from the strong base. Okay, so we have water molecule over here being produced because the H and the OH will combine and forming the water molecule. So that is just some H2O. We're not going to be looking at that. We're just going to be looking at what will be happening to this salt right here. So in water, the CH3COO-Na is completely dissociated into cations and anions. I think by now, at this part of the video, all of you should be able to understand or at least remember that all of the salts will be completely dissociated in aqueous solution, or in other words, in water. So when we have the salts dissolve in aqueous solution, we will be making the anion CH3COO-. That one will be in aqueous solution. And we have the Na plus cation. Remember, the ionic species that is originated from strong base or strong acids, this is originated from the strong base, therefore it will not going to be reacting or hydrolyzing water. Whereas your anion in this case, CH3COO-, came from weak acid, thus it will surely going to be hydrolyzing with water molecule. I have written over here cation from strong base. Same goes to anion. If it's from the strong acids, they will not going to be hydrolyzing water molecules when they are added with water. But in the case of this anion, which is from the weak acid, the anion that we have just now is CH3COO-. So that is the anion that we have. What will happen to that one? Same goes to what we had in the example right here just now. So if in the case of strong acid plus weak base, the cation donates H plus to the water molecule, it will be the opposite for this case. Okay, so in this case, what will happen? It will receive the proton from H2O. Okay, so the anion, in this case CH3COO-, accepts proton H plus from H2O liquid to form and we will be forming OH minus aqueous. So when we have OH minus aqueous being formed, it gives you the idea that the salt is a basic salt. The solution will have pH greater than 7. So the example right over here, we have the salts, okay, dissolved in aqueous solution. You will have this anion being produced and the cation right there. This cation from the strong base, so it will not going to be reacting with water molecule. But this anion came from weak acid, so it will be reacting with the water molecule and it will accept the proton from water molecule, like what you have seen over here. You have this CH3COO- from weak acid. It came from weak acids, therefore in this form it will be quite strong, and it will take one of the H from water molecule, and the water molecule will be converted into OH-, and now you have CH3COOH. Look at that H, that is black in color. That means it came from the water molecule that dissolves this anion. Okay, so we have OH- formed, and the pH of the salt solution will be greater than 7. So when that is going to be greater than 7, we can say that this is a basic salt. Okay, so when you look at what we have done here, it is less than 7 for strong and weak because H3O+ is formed when salt is dissolved in water. So in the case of this, it will be greater than 7. Why? Because OH- is formed when the salts dissolve in water. Okay? Thus, we have a basic salts. Other examples of basic salts, we have Na2CO3 and Na3PO4. This is the summary. The the table that you can have a look to summarize of what we have discussed throughout this video.